So could you repeat what you're about to do again?
I haven't gotten there yet. I'm just doing my introduction. I got it.
Could you do the introduction again?
No, I'm Brianna. I'm a chemist. I'm here to teach them science.
All right.
Okay, so you guys, do they still have their folders? The periodic tables?
No.
Oh,
We'll get some copies of the periodic table.
Nope, they should know it by now. So, on the periodic table of elements, you have elements that are in a box. There's one on that probably should be ready to grab now. So,
I got to know for their colors and everything.
oh yeah, let me get it.
Ooh. Give me.
Go ahead, you go for it. So on the periodic table, you have a bunch of different elements. And everything that we are, everything that's around us, and everything that we eat, we breathe, we see is all made up of these elements on the periodic table. Don't make me move you three. Yeah, I see you. So, what I want to talk about is the components of an element. So if I draw my box, like these boxes on here, I need you guys to tell me what goes inside of the box for an element. Arson.
The periodic symbol.
Yep, periodic symbol. What you got, Chrissy?
Mass.
Mass, good. Mass for carbon is 12.011, I think. What's this?
Moles.
Grams per mole, but what do we call this? Starts with a U. What is it? A unit, very good. Okay, what else? What you got?
The name.
The name. That's carbon for C. What you got?
The number, the atomic number.
And the atomic number, and I think it's 6 for carbon. Good. So these are what the elements look like on the periodic table. What about what do we call two elements that are together like this? What do we call that? You can blurt it out now.
Bond.
That's what holds the elements together. It's a bond. A molecule. Good. It's called a molecule.
Young lady, put your legs down.
And what is a bond made of?
2 electrons.
2 electrons. Good. You write electrons like that. What if I ask you some directionality? What about electronegativity? Does it increase going up or down or left or right on the periodic table? Up and right. Electronegativity increases going to the right and
Down.
up and up. So that means the more we go to the right of the periodic table, the elements want to soak up electrons. And the more we go up the periodic table, the elements want to soak up electrons. Does that make sense? Okay, so what if I ask, what else did I teach you guys about? The life cycle of a plant. What do you start with when you're trying to grow a plant? A seed. Then you go to germination. So you add some water to your seed, and you add some darkness to your seed. So let's just say my son, and I put an X around it so it's dark. And that germinates the seed. And then what happens when you germinate the seed? It becomes a seedling. And then what's next?
Plant.
A root.
I think it sprouts. So your seed then sprouts. You get this cute little thingy. Let's pretend that's green. And then what about after sprouting?
Plants.
You have a plant. So you still got your seed down there with your roots. I know my drawings are terrible. You got a plant. What's after my plant?
Plant with flowers or fruits.
Good. My plant with flowers or fruit. So let's just say that's an orange. Okay. Okay, so that's the life cycle of a plant. What about, somebody tell me the primary chemicals that are needed in soil? Blurt it out. Water. Primary chemicals.
Water.
I need chemicals, not just everything. Nitrogen,
Phosphorus and calcium.
potassium, and
Phosphorus.
Phosphorus. Good job. Ooh, I wrote that backwards. Because they call it NPK. What does a plant need to survive? water, and what else?
Sun.
Oxygen.
Soil.
Soil.
And when you give, okay,
Power.
let's talk about a plant. So the plant has roots, right? What else does it have?
A stem.
It has a stem, and it has leaves,
Sometimes a flower.
sometimes a flower,
Stem.
and we'll call the flower and fruit the same thing.
Stem.
So, how does the water get to the plant? Through the roots. Through the roots, through the stem takes it to the leaves, and takes it to the fruit. What about how does carbon dioxide get soaked up by the plant?
I think it produces oxygen.
The plant produces oxygen, but it needs carbon dioxide to produce it, and it gets carbon dioxide from us. Remember, we breathe.
We
breathe.
inhale.
Exhale.
We
Exhale.
inhale oxygen. We breathe out carbon dioxide.
I thought it was extra.
So, how does the plant take in carbon dioxide? Through the leaves, the bottom of the leaves, right? You have to have pores in them. I think that's all we know of plants. What if I ask, how do you find how many protons are on the periodic table? You can word it.
The number.
The number.
Yeah, atomic
number.
Yep, how do you find neutrons?
Mass minus number.
Mass minus number.
Good, you subtract the mass minus the atomic number. What's her name? Wakey, eggs and bakey, what's your name? Christine, wake up, sit up. There we go. All right, so what if I ask, this is my last question. What if I ask, okay, you guys remember the invisible ink project that we did?
Yeah.
How did the bonds break for the invisible ink to be able to be visible? Heat, good. Heat, we show heat like this. And it breaks the bonds. Okay, that's all I want to work on for a recap. I think you guys are there. I'm so happy y'all were able to soak that up and be able to regurgitate it back to me. So, what I want to teach you guys about today are membranes. You say membrane?
Membrane.
Good. Membranes are something that's on the outside that protects what's in the inside from things that pass through or things that are not allowed to pass through. Right? Right? What's your-
If I remember correctly, there are both permeable membranes and non-permeable.
Very good. But we ain't going that deep yet. But very good. So my skin can be an example of a membrane. The peel on this fruit can be an example of a membrane. Right? Does that make sense?
Yeah.
Yes. Okay. And this. Oh, really? Well, we tried. Maybe it's because it's not on.
What you trying to do?
Mirror.
Mirror. Everybody in.
I know how to do it, just wasn't
That's okay. We'll use it next time.
What's that right there? Oh.
Okay, so we understand what membrane is. Now, osmosis. Can anybody tell me what osmosis is?
The process of water diffusing through a membrane.
Very good. Osmosis can be more than water. Very good answer. But it is what allows something to get through the membrane. Okay? And then we have acids and bases. So this is what we are focusing on for today, okay? What I want us to do, and I'm just gonna show you on my phone, I know it's not gonna be big, but I'm gonna try big Can everybody see my phone? Yes, one second. What I want us to do is to make an invisible egg. egg. So I want us to get rid of the shell and be able to make an egg bounce without it bursting. Okay? Yes.
I was gonna say something about the acid and base. That's like the pH scale, right?
Yes, your
But,
pH scale does deal with acids and
With
bases.
the egg that we like with vinegar.
Yes. We're going to use vinegar as an acid to get rid of calcium carbonate, which is a part of this gel. And I brought some eggshells for y'all, thanks. But calcium carbonate, which is also found in our bones, is the barrier that's around this egg. It's its shell. So we're going to use acid, which is vinegar, to get rid of the calcium carbonate, and you'll see the acid-base reaction happening. And what gas is released with the acid-base reaction? Carbon dioxide. Good. You'll see the carbon dioxide from the bubbles, because you know, you already know. All right. Oh,
So it's not.
calcium carbonate. That's our base, right? Vinegar is going to get rid of calcium carbonate, so that we'll release some carbon dioxide, and we'll be left with just that really soft, bouncy membrane. You should be able to drop the egg and it bounce instead of burst. Okay? So let's see. How can I do this? I'm going to choose. This is how we'll do it. Yep. I can hear you. Okay. Go do your thing, girl. You put your hands up, put your hands up, put your hands up. I want to choose those who I got the most participation from today to be my little parent and take care of this experiment. So what's your name? Dimitri and Christy and Arson and
I have too much time that I can't spend on stuff.
okay, you don't have free time. Got it. What's your name? JC. JC. And what's your name?
Nate,
Yes.
Nate,
Nate, JC, Dimitri, Chrissy. 1, 2, 3, 4. See, I was gonna say Megan, but last time I called you Jayla, and you got real mad at me, so I just wanted to make sure because you got real mad at me. But I know your name, Megan. Don't do me like that, Megan. Don't do me like that. You see the face? She upset me already. So 1, 2, 3, 4, 5. Ups, ups. Don't make me move, y'all. Come on now. I need 2 more. All right, I got my 6. You don't wanna?
I do.
Okay, and my 7. All right. So, and I have my glass, and I'm gonna let you guys do this experiment. We're not gonna worry about gloves and all that fancy stuff because we're not gonna worry about gloves and all that fancy stuff because it's just vinegar and it's just eggs. So, the object of this experiment is for us to take this mason jar, and we're going to put our egg that is covered in calcium carbonate into the mason jar without bursting it. And we're going to cover it or fill the container just to cover the egg with vinegar. Those who I called on, raise your hand if you don't have vinegar at home. I know your mama got vinegar at home. I don't know why you trying to
I
wait.
don't know who my hand out.
What about apple? Well, apple vinegar?
We need regular white vinegar.
Yeah, we got that.
Yeah, so everybody has vinegar at home?
Yeah.
Yes. Okay, so the object is for you to cover this with vinegar, to close it, put it in your refrigerator, let it work its magic, and every day you have to open it up, take the vinegar out, refill it with clean vinegar, close it back, put it back in the refrigerator. Make sense?
Yeah.
For 2 days. 2 days, and then you guys y'all got practice on Saturday? Because my plan was to do this on Tuesday, but y'all had some stuff going on.
nobody come on Saturdays.
Dang.
No,
I come on Saturdays all the time.
No, this Saturday we doing something. Coach was going to go help clean up the block.
What?
That's why I made that part.
Oh, that's what y'all doing. First off, you taking up the North Line on Saturday? Why you saying like that? Why you say it like that?
I don't know how to save it to the platform.
Oh, I'll do it, Dad. I just haven't use Google Docs, so it's a little difficult.
I gotta have it ran off before tonight.
Okay, I'm almost done with my experiment. I'll do it.
All right, go ahead.
Okay, so raise your hand if those who I called on, raise your hand if you're not coming on Saturday. You're not coming on Saturday?
I am coming.
No, not you. I don't know if I'm coming.
Okay. Trying to figure out how we're gonna do this, because it's a 2-day experiment.
Maybe.
2 days.
That's why I need them to bring it back on Saturday.
Well, I'm not coming. My dad dropped it
It's ready.
Oh, you're coming.
off.
Because I'll be there with you guys on Saturday. We'll figure it out. Okay, so I might have to replace you.
Come on.
Will you be there Saturday? You don't know yet?
Wait, so I have to be here on Saturday?
Yeah. Okay, so what you can do is every day you're gonna refill your container with vinegar, and then on Saturday we'll bring it, and whoever egg bounces the highest without bursting will receive a prize. We'll figure out what prize. We'll figure it out.
Maybe $20.
More than
No,
that.
I live like $30.
We can debate about it.
Coach, can I use yours?
Yeah, what is?
We'll figure that out. So, yeah, are there any questions so far about this experiment?
I can show you how the egg bounced on the TikTok I had. The egg bounced until she put it in an area where it's rocks at it first.
So I'm just gonna do the first egg, and it's a real simple experiment. And I'm just doing it to replace Kamari. And I'm gonna have, because he's not gonna be there Saturday. And I'll have my own egg to, put your shirt down. I'll have my own egg to take care of it.
Is the calcium base?
Calcium carbonate.
That's a lot.
Carbonate, same thing that's in our bones. And you guys see the bubbles already releasing? Yes.
Leave me alone.
And that's all. So my 7 people, you can come up and get your mason jar and grab an egg, and do not drop that egg.
Yes, she did.
She did.
She did.
Wait.
Bro, calm down. All that silly stuff. Don't even.
One, two, three, four, five. Oh no.
We got the air fryer.
I might even have 7. Okay, I might have lied.
If I don't do this now, I might see it on my product so I can do it.
I might only have
Pay attention to it. It's gonna be on
3.
video.
I don't want to break the egg.
Say, I'll see if I can get
If you turn the mason jar to the side, when you put the egg in, then you won't have to worry about it breaking when you put it inside. Take your time.
I think crack.
Did it crack?
A little crack, but it's not crack.
It'll be alright.
It's still cracked though. Yeah, but
It'll be
What are you
okay.
doing? But stop acting silly,
Because
man.
the part that cracked is the shell, and it's gonna disintegrate with the acid in it anyway.
Oh, wait, we're gonna put the beginner in here now.
no, we just gonna sit here.
And what must the scientists do after they put something in the container? Label it. Something like that.
I'm gonna label it R2D2.
You know what? You grow up.
You got a shot of that?
No.
Yeah, it's okay.
You know you didn't, Sean. I know it.
Oh, I got shot of
Here's some tape. Here's some white tape.
Oh, that'll work. White hair, right?
Now you can take a small portion of white tape. Here's some scissors.
Okay. My helper scientist, what are you to do every day?
Check. Give it new white vinegar.
Won't you need some like a sharp? Won't you need a sharp something?
Every day replace it with new vinegar.
What if they're not here? Who else gonna step up?
No, they're taking them home.
So I need the tape. Where's the tape at?
I might see if I can get my own how to.
It's in my